Hello everyone, this is the industrial age. In today's video, we are diving into fascinating world of material requirement planning or shortly MRP. In this video, I will be exploring the foundational concept of material requirement planning. So let's get started. Start with what is material requirement planning. To begin, let's establish a clear understanding of what material requirement planning is. Material requirement planning is a systematic approach used in manufacturing, production management, and supply chain management to plan, schedule, and manage the materials needed for production. MRP helps ensure that the right material are available at the right time and in the right quantities to meet production demand while minimizing excess inventory and associated cost. Now, material requirement planning in short. MRP is a production and inventory management methodology. MRP ensures timely availability of material for production processes. MRP balances demand forecast, inventory level, and production schedules. MRP is essential for optimizing resource allocation and minimizing cost. MRP utilizes data-driven analysis for efficient material procurement and utilization. Now discussing on evolution of MRP. Four basic stages are considered in the evolution of MRP. We'll discuss one by one. Stage 1. The first generation of MRP system focus on calculating material requirement based on bill of material and production schedules, enabling better coordination of production activities. Stage 2. In the 1980s, MRP2, that is Manufacturing Resource Planning, emerged, broadening MRP's scope beyond materials by incorporating features such as capacity planning, shop floor scheduling, and financial integration. This expansion offered a comprehensive view of the production process, encompassing both material allocation and broader operational resource management. Stage 3. The subsequent evolution led to the integration of MRP2, that is Manufacturing Resource Planning, with other business functions, giving rise to Enterprise Resource Planning, that is ERP, system in the 1990s. Stage 4. The infusion of cloud computing, the real-time data synchronization, and predictive analytics has elevated supply chain agility and responsiveness. Concurrently, MRP systems have embraced Industry 4.0 principles, integrating concepts like the Internet of Things, that is IoT, to establish dynamic smart manufacturing setting featuring real-time monitoring and adaptable production capabilities. Now discussing about importance of material requirement planning. So material requirement planning is a critical concept and tool in modern manufacturing. It plays a pivotal role in optimizing production processes, managing inventory, and ensuring efficient resource utilization. Now we can discuss the importance one by one. First, efficient resource planning. MRP ensures optimal allocation of material, labor, and equipment, minimizing wastage and enhancing resource utilization. Second, inventory optimization. It prevents overstocking or stockout by calculating precise material requirements, reducing carrying cost and production interruptions. Next importance, production scheduling. MRP helps create realistic and achievable production schedules, improving on-time delivery and customer satisfaction. Next importance, complex bill of material management. It handles intricate bill of material, that is BOM structures, managing dependencies between component and sub-assemblies seamlessly. Next importance, lead time management. By factoring in lead time for material and processes, MRP minimizes delays and ensures timely production. Next importance, demand forecasting. MRP uses historical data and trends to forecast demands, allowing manufacturers to plan ahead and meet customer need efficiently. Next importance, cost reduction. Effective MRP implementation reduces excess inventory cost, production downtime, and rush orders, leading to overall cost saving. Next importance, customer centric approach. MRP ensures products are available when customers need them, fostering loyalty and positive brand perception. Next importance, adaptation of Industry 4.0. Modern MRP system incorporate IoT, AI, and data analytics to align with Industry 4.0 principles and enable smart manufacturing. Next importance, continuous improvement. By identifying bottlenecks and inefficiencies, MRP support continuous process improvement initiatives. Next importance, compliance and traceability. MRP aids in meeting regulatory requirements and quality standards by tracking material and process meticulously. Next importance, supply chain coordination. MRP enhances communication and collaboration across the supply chain, fostering better relationship with supplier and partners. Next importance, real-time insight. Advanced MRP solution provide real-time visibility into production status and inventory levels, enabling proactive decision making. Scalability. MRP system can accommodate business growth and changing production needs, ensuring long-term operational viability. Now, the key objectives of MRP implementation. The key objective of MRP implementation revolves around enhancing operational efficiency, optimizing resource utilization, and ensuring timely production. It seeks to enable effective production scheduling, reduce lead times, and facilitate data-driven decision making, ultimately fostering better coordination among various departments and stakeholders. Now we discuss one by one. So the first key objective, to optimize inventory management. MRP aims to minimize excess inventory and stockout by calculating accurate material requirements based on demand forecast and production schedules. Next key objective, to plan capacity effectively. MRP considered production capacities and constraint, preventing overloading or underutilizing resources and maintaining a balanced production flow. Third key objective, to improve production planning. MRP assists in creating efficient production plans that align with demands, capacity, and resource availability, leading to smoother production processes and reduced lead time. The fourth key objective, to minimize work in progress. By synchronizing production stages and material flows, MRP reduces excessive work in progress inventory and production bottleneck. Fifth key objective, to enhance resource utilization. By coordinating materials, labor, and equipment effectively, MRP maximize resource utilization and minimize underutilization, leading to cost saving. Sixth key objective, to provide comprehensive technical support. MRP systems are scalable and adaptable, supporting business growth and expansion. Seventh key objective, to ensuring timely order fulfillment. MRP ensures that products are manufactured and available when needed, improving on-time delivery and customer satisfaction. Eighth key objective, to improve process. By identifying inefficiencies and bottlenecks, MRP encourages a culture of continuous improvement and optimization. Ninth key objective, to reduce production cost. MRP helps minimizing setup cost, changeover time, and overproduction related expenses through optimized scheduling and resource allocation. Tenth key objective, to integrate with technology. Modern MRP systems incorporate advanced technologies like IoT, AI, and data analytics, align with Industry 4.0 principles and enabling smarter manufacturing. 11th key objective to streamline communication. MRP enhances communication and collaboration among different departments and stakeholders, ensuring a synchronized approach to production and procurement. 12th key objective to utilize data-driven decision making. MRP provides data and insight that aid informed decision making, allowing companies to adapt to change in demand or supply and make strategies choices. 13th key objective to forecast demand accurately. MRP utilizes historical data and trends to forecast demand, enabling businesses to anticipate fluctuations and plan accordingly. 14th key objective to coordinate supplier. MRP facilitate coordination with supplier by providing accurate material requirements, improving lead times, and strengthening supplier relationships. Overall, MRP implementation aims to create a well-coordinated, efficient, and responsive production environment that meet customer demands while minimizing cost and maximizing resource utilization. Now next we are going to discuss about key concept or components of material requirement planning. The term component of material requirement planning refers to the various essential element or building blocks that make up the material requirement planning process and system. So we are going to discuss all this one by one. The first is Master Production Schedule, MPS. The plan specifying that finished product need to be produced, in what quantity and when. The MSP provide the production schedule and demand data for MRP. Second, Bill of Material. The structured list detailing the components, sub-assemblies, raw materials required to manufacture a finished product. The BOM forms the foundation of MRP calculation. Third concept or component, capacity planning. Evaluating and balancing production capacity against demand to ensure resources can accommodate the production schedule. Fourth key concept, inventory records. Information about the quantities of material currently in stock, including on-hand inventory, schedule receipt, that is incoming material, and orders, that is outgoing material. Fifth, BOM explosion. Breaking down the requirement of finished product into the necessary sub-assemblies, components, and raw material based on the BOM. Sixth, safety stock. Extra inventory held to mitigate uncertainties in demand or supply. MRP considers safety stock level to prevent stockout and production disruption. Seventh key concept, lot sizing. Determining the order quantities of material or component to optimize cost efficiency and inventory holding cost. 8. Continuous monitoring and updates. MRP system continuously update and recalculate requirements as new data become available. Ninth key concept or component, gross and net requirement. Gross requirement present the total quantities needed for production, while net requirement account for existing inventory and schedule receipt. Net requirement guide purchasing and production decision. 10th key concept or component, exception management. Identifying and addressing discrepancies between plan and actual production or inventory level. 11th key concept or component, order generation. MRP generates recommendation for purchase order or production orders for the component and material needed based on the calculated requirements. 12th key concept or component, time fences. Specific time intervals during which production schedules are relatively flexible due to customer commitment or production certain or production constraints. 13. key concept or component, lead time. The time is taken for material to be procured, manufactured or transported from the supply to the production facility. Lead time affect when material need to be ordered or reproduced or produced. These components collectively contribute to the MRP process, facilitating the planning, coordination, and optimization of material, resources, and production activities to meet customer demands efficiently and minimize cost. Now, here are some advanced concepts related to the material planning. So, advanced material planning MRP concept build upon the foundation of traditional MRP to address complexities and uncertainties in modern supply chain and manufacturing environments. These concepts leverage technology, data analytics, and optimization techniques to enhance the accuracy, agility, and efficiency of material planning and procurement. Now we can discuss one by one. The advanced concept of MRP. First, demand driven MRP, and in short we call it as DDMRP. Demand driven MRP focuses on aligning material replenishment with actual customer demand rather than relying solely on forecast. It introduces concepts like buffer management, where strategically placed buffer or inventory are used to absorb demand variability and supply chain disruption. DDMRP dynamically adjusts buffer level based on actual consumption rate and lead time variability, ensuring more accurate and responsive inventory management. Second advanced concept is multi-echelon MRP, in short MEMRP. MEMRP extend the MRP process to consider multiple levels of the supply chain, incorporating intermediate suppliers and distribution centers. By coordinating inventory and replenishment across these echelons, MEMRP aims to optimize overall inventory levels and reduces the bullwhip effect, the amplification of demand variability as it moves upstream in the supply chain. The next advanced concept is integrated business planning, in short IBP. Integrated business planning integrates various planning functions, including financial planning, sales and operation planning, supply chain planning, to agile strategic objective with operational execution. IBP uses advanced analytics to simulate different scenarios and make informed decisions that balance demand, supply, and financial goals across the organization. The next advanced concept of MRP is constraint-based planning. Constraint-based planning considers production capacity constraint when generating material plans by factoring in resource availability, machine capacities, labor hours, and other production limitations. This approach ensures that material plans are feasible and achievable, preventing overload and bottleneck. The next advanced concept of MRP is advanced forecasting technique. Advanced forecasting methods such as time series analysis, machine learning algorithms, and predictive analysis enhance demand forecasting accuracy. These techniques can capture complex patterns, seasonality, and external factors that influence demand, leading to more reliable material requirement projections. Next advanced concept of MRP is supplier collaboration and visibility. Advanced MRP emphasizes collaboration with supplier, enabling real-time data sharing and visibility into supplier capacities, lead times, and inventory level. This collaborative approach enhances supply chain resilience and enables timely adjustment to material plan based on supplier capabilities. Next advanced concept is real-time data integration. Integrating real-time data from various sources such as sales order, production updates, and inventory movement enables MRP system to respond more quickly to changes in demand and supply. This dynamic data integration enhances the agility of material planning and ensures accurate calculation. Next advanced concept, scenario modeling and optimization. Advanced MRP system incorporates scenario modeling and optimization techniques to evaluate different planning scenarios. By analyzing various what-if scenarios, these systems help organizations make informed decisions that minimize cost, reduce lead time, and optimize inventory levels. Next advanced concept is lean and agile principle. Advanced MRP often incorporate lean and agile principles, focusing on reducing waste, improving flow, and enhancing responsiveness. By eliminating non-value added activities and optimizing production processes, organization can achieve better alignment between material procurement, production, and customer demand. Next advanced concept of MRP, artificial intelligence, that is AI, and machine learning, that is ML. AI and ML techniques can analyze historical data, identify pattern, and predict future demand and supply trend with greater accuracy. These technologies enhance the ability of MRP system to adapt to changing conditions and provide actionable insights for decision making. So, implementing these advanced MRP concepts require a combination of technology investment, process redesign, cross-functional collaborations, and change management. Organizations that successfully adopt these concepts can achieve higher level of supply chain efficiency, reduce inventory cost, improve customer service, and enhance competitiveness in today's dynamic business landscape. Relation between material requirement planning and bill of material. The bill of material, that is BOM, serve as the foundation of MRP calculations and plays a vital role in planning and managing production process. The BOM is a structured list that outlines the components, sub-assemblies, and raw materials required to manufacture a finished product. Now we are going to discuss the relation one by one. So the first point is input for MRP calculation. The BOM provides the necessary information for MRP to calculate material requirement. It breaks down the finished product into constituent parts, allowing MRP to determine the quantities and timing of materials needed to fulfill production schedule. Second, bill of material explosion. MRP utilizes the BOM to explode or drill down the requirements for higher level assemblies into the material and components needed for lower level assemblies. This is a crucial step in MRP calculation to determine the net material requirement. Third point, calculating requirement. MRP uses the BOM structure along with other data like the master production schedule, inventory level, and lead time to calculate gross and net material requirement for each component and raw material. Fourth, order generation. Based on the calculated requirement, MRP generate a recommendation for purchase order or production order for the component and material needed. These recommendations ensure that material are available when required for production. Fifth, lead time consideration. The BOM provides information about the lead time associated with each component. MRP takes these lead time into account to determine when order should be placed or production should be initiated to meet production schedule. Next point is assembly planning. The BOM helps MRP to plan the assembly process by ensuring that all necessary components are available at the right time for each level of production. This coordination prevents production delays and disruptions. And last, bill of material update. As changes occur, such as design revision or substitution, the BOM is updated. MRP relies on the accurate BOM data to ensure that calculations and recommendations are aligned with the latest product configuration. The bill of material is an essential element in the MRP process, providing the structure and detail needed to calculate material requirement, generate purchase and production order, and ensure smooth and well coordinated production process. The accurate and up-to-date BOM information is crucial for MRP system to effectively plan and manage production activities. So this is all about relation between MRP and BOM. Relation between material requirement planning and master production schedule. The MPS means master production schedule serve as a key input to MRP calculation and provide the production schedule for finished product. Now we are going to discuss the relation one by one. So the first point is input for MRP calculation. The MSP is a fundamental input for MRP. It specifies the production requirements for finished product over a specified time horizon. MRP uses this information to determine the material requirements necessary to meet the MPS, means master production schedule. Second point, demand for raw materials and component. MRP uses the MPS, master production schedule, to calculate the gross material requirements for the finished products listed in the schedule. It then breaks down these requirements into net requirements by considering existing inventory level, schedule receipt, and order points. Third, time phase planning. The master production schedule provides a time phase plan for production. MRP align with this plan with the required material quantities and timing, ensuring that the necessary components and materials are available when needed for production. Fourth, coordination of production. MRP uses the master production schedule to coordinate production activities with material availability. It generates recommendation for when to start production run or place order for raw material based on timing specified in the master production schedule. Fifth, rescheduling and adjustment. If changes occur in the master production schedule due to the shift in customer demand or other factors, MRP adapts accordingly. It recalculates material requirement and adjusts recommendation for purchasing and production to accommodate any changes in the schedule. Sixth, inventory impact. MRP considers the master production schedule in its calculation to ensure that sufficient inventory is available to support the production schedule. This prevents stockout and production disruptions while minimizing excess inventory. Seventh, capacity consideration. MRP take into account the MPS, means master production schedule, when evaluating production capacity. It ensures that material requirements derived from the MPS align with the available capacity, preventing overloading or underutilizing production resources. And the last, feedback loop. As MRP generate recommendations for order and production based on the MPS, the actual production and inventory level are updated over time. These updates provide feedback that can influence future MPS adjustment and overall production planning. So basically, the master production schedule is a pivotal input to material requirement planning. It guides the overall production plan and finished product and set the stages for MRP calculations, helping ensure that materials and components are available to meet production needs and fulfill customer demands. So this is all about relation between material requirement planning and master production schedule. Next, we are going to discuss step-by-step process to apply MRP in industry. So the first step, demand forecasting and analyzing. Collaborate with sales, production and other relevant departments to gather demand forecast for products or material. Second, analyze historical demand pattern, market trends and customer order to project future material requirement. Second step, inventory assessment. So reviewing existing inventory level for each material and product and determining order point and safety stock level to ensure adequate inventory to meet demand and account for variability. Third step, bill of material analysis. Review and maintain accurate bill of material that details the material and component required for each product. Ensure bill of material are up to date, reflecting any design changes or improvement. Fourth step, master production schedule development. Create a detailed production schedule based on demand forecast, customer order, and inventory level. Align production with demand while considering capacity constraint and lead time. Next, net requirement. Calculate the net material requirement by subtracting existing inventory and schedule received from the total required capacity. Now the sixth step, MRP system input. Enter the net requirement, lead time and other relevant data to the MRP software system. Seventh step, procurement planning. Generate purchase requisition or purchase order for a material needed to fulfill the net requirement. Consider supplier lead time, order quantities, and pricing to optimize procurement decision. 8th step, supplier communication. Coordinate with the procurement or purchasing team to ensure timely communication with supplier. Provide accurate and timely information to supplier regarding order quantities, delivery dates, and specification. Ninth step, order tracking and follow-up. Monitor the status of open purchase order and ensure timely deliveries from supplier. Address any delays or issues that may arise during the procurement process. 10th step, production coordination. Collaborate with production and manufacturing teams to ensure the availability of material as per the production schedule. Adjust schedules and material allocation based on changes in demand or production capacity. 11th step, inventory management. Regularly review inventory levels to prevent outstocking, overstocking, or stockout. Implement inventory optimization techniques to minimize carrying cost while meeting demand. 12th step, continuous improvement. Analyze MRP performance and accuracy, identifying areas for improvement. Implement process enhancement to streamline operation and enhance efficiently. Third step, data analysis and reporting. Generate report and analysis related to the material requirement, procurement activities, and inventory stock levels. Provide insight to management for decision making and strategic planning. 14th step, cross-functional collaboration. Work closely with cross-functional team including procurement, production, sales and finance to ensure alignment and effective execution. 15th step, adaptation and flexibility. Respond to change in demand, production schedule, or supply chain disruption by adjusting MRP plans accordingly. So this is a step-by-step process to apply MRP in industry. Now related to the same, an MRP engineer's role is very crucial in maintaining a well-functional supply chain, optimizing material availability, and contributing to the organizational operation efficiency. The steps mentioned above provide a general overview of the typical tasks and responsibilities involved in the role. However, specific process and responsibility may vary based on the organization's industry, size, and operational requirement. Now, next point is handling variation in MRP calculations. Handling variation in MRP calculation is crucial to ensure accurate and effective production and inventory management. Variation can arise from changes in customer demand, supplier lead time, production constraint, and other factors. So discussing different variations one by one. Regular monitoring and updating. Keep close watch on actual demand, production schedules, and inventory levels. Regularly update MRP parameters such as lead time, order quantities, and safety stock level to reflect the latest data. Also, adjust the MRP calculation based on the real-time information to align with current conditions. Secondly, demand forecasting. Enhance your demand forecasting techniques to better predict changes in customers' order and market trends. This will help you anticipate variation and adjust your MRP calculation accordingly. Third, safety stock. Maintain an appropriate level of safety stock to absorb unexpected variation in demand or supply. Supply stock act as a buffer, allowing you to manage fluctuations without disrupting production or customer orders. Next point is reorder point. Set reorder point at a level that account for variation in lead times and demand. A well-calibrated reorder point triggers new order before you run out of stock, helping to address sudden change in demand. Fifth point, supplier collaboration. Collaborate closely with supplier to gain visibility into their lead time and potential disruptions. Share demand forecast and production schedule to help supplier plan better and reduce lead time uncertainties. 6. Capacity planning. Evaluate your production capacity and constraint regularly. Adjust MRP calculations to align with available capacity and account for variation in production rates. 7 point. Scenario planning. Use scenario analysis to simulate the impact of different variations in your MRP calculations. Also, explore what if scenario to understand how changes in demand, supply or production constraint would affect your inventory level and production plans. 8. Flexible production scheduling. Implement flexible production scheduling techniques such as just-in-time or lean manufacturing to quickly adapt to changes in demand and reduce the impact of variation. Ninth point, exception management. In that, implement exception management practice to quickly identify and address variation that deviate significantly from the planned MRP calculations. Also focus your attention on managing exceptional cases that require immediate action. 10th point, continuous improvement. Continuously analyze and evaluate the accuracy of MRP calculation. Use historical data and feedback from production and inventory management to fine-tune your MRP parameters and improve forecasting accuracy. Technology and automation. Leverage advanced MRP software systems that offer automation, data analytics, and predictive modeling capacities. These systems can help handle variations more effectively by providing real-time insight and generating accurate MRP calculations based on up-to-date information. Now, handling variation in MRP calculations require a combination of proactive planning, collaboration, accurate data, and the ability to adapt to changing circumstances. By implementing these strategies, you can better manage uncertainties and maintain efficient production and inventory management process. Now, challenges in MRP calculation. Material requirement planning (MRP) is a complex process used by organizations to manage and plan their inventory, production, and procurement activities. While MRP offers numerous benefits, it also comes with several challenges that can impact its accuracy and effectiveness. So, the first point, here are some detailed explanation of these challenges. First, data accuracy and integrity. MRP relies heavily on accurate and up-to-date data, including inventory level, lead time, bill of material, and production schedule. Inaccurate or incomplete data can lead to incorrect calculations and decisions. Maintaining data integrity and ensuring regular updates can be challenging, especially in dynamic manufacturing environment. Second point, lead time variability. The lead time required to procure material can vary due to factors such as supplier delay, transportation issue, or unexpected disruptions. MRP systems often use average lead time, but real-world fluctuations can lead to either excess or insufficient inventory levels. Third point, BOM complexity. Accurate bill of material are crucial for MRP as they define the material and component required for each finished product. Complex and multi-level BOM with numerous parts can introduce error if not properly managed and updated, leading to inaccurate material requirement. Fourth, demand forecasting. Accurate demand forecasting is essential for MRP to determine when and how much to order. Accurate demand forecasting is essential for MRP to determine when and how much to order. Fluctuating customer demand, seasonal trends, market changes, and new product introduction can challenge the accuracy of demand forecast, leading to overstocking or stockout. Fifth, batch and lot sizing. Determining the optimal batch or lot sizes for production and procurement is delicate balancing act. MRP need to consider factors like production cost, storage constraint, and demand variability. Choosing inappropriate batch size can result in excess inventory, increased carrying cost, and efficient resource utilization. Sixth, capacity constraint. MRP system may not always take into account production capacity limitations, leading to plans that cannot be feasibly executed. Overloading certain work centers or machine can disrupt the production schedule and cause delay. Seventh, dynamic production environment. In environment where production process and lead time frequently changes due to customization, rush order or process improvement, MRP system may struggle to adapt quick enough to maintain accurate material requirement. 8. Synchronization and communication. MRP involves various departments and functions, including production, procurement, inventory, and sales. Lack of effective communication and coordination among these departments can lead to misunderstanding, delay, and misaligned plans. Ninth, rapid changing market. In industries with rapid changing market, new product introduction or shift in customer preferences can impact the demand for existing product. MRP system may require frequent adjustment to accommodate these changes. And last point, that is 10th, external disruptions. Unforeseen events such as natural disaster, supply chain disruption, economic downturns, or geopolitical issues can significantly impact the availability of material and disrupt the MRP process. Now, addressing these challenges require a combination of accurate data management, sophisticated forecasting method, adaptive planning strategies, effective cross-functional communications, and robust MRP system customization. Overcoming these challenges can lead to more efficient material procurement, reduce inventory cost, improve production scheduling, and enhance overall operational effectiveness. So this is all about challenges in MRP calculations. Now next we are going to discuss about optimizing MRP for business system. Optimizing a material requirement planning system for a business involves a systematic approach that combines technology, processes, and people to improve efficiency, accuracy, and overall performance. Here, a step-by-step guide to optimize MRP for your business system is placed. So we discuss the steps one by one. So the first point, assessment and planning. In assessment and planning, the first, understand business need. Identify the specific challenges and goal of your business. Determine what aspect of your MRP system need improvement and how optimization align with your overall business objective. Second, gather data. Collect comprehensive data on inventory level, lead time, production schedule, demand forecast, and supplier performance. Analyze historical data to understand patterns and trend. Define metrics. Establish key performance indicator to measure the success of your optimization efforts. Example, include on-time delivery, inventory turnover, and production schedule adherence. Now, second step in optimization, data management and accuracy. In data management and accuracy, cleanse and validate data. The first point in that. Review and clean your data to eliminate duplicates, inaccuracies, and ordered and outdated information. Ensure that data input processes are standardized and error-free. Automate data entry. Implement automated data capture process such as barcode scanning or RFID technology to reduce manual effort and improve data accuracy. Third step in optimization is advanced forecasting. In advanced forecasting, first, utilize advanced method. Implement advanced forecasting techniques such as time series analysis, machine learning algorithms, and predictive analysis to improve demand forecasting capacity. Incorporate external factors. Consider external factors that impact demands such as market trends, economic conditions, and seasonality when generating forecasting. Now, fourth step in optimization, lead time management. Fourth step in optimization, lead time management. In lead time management, the first, dynamic lead time. Incorporate lead time variability and supplier performance data to calculate more accurate lead time. Update lead time regularly based on actual performance. Buffer management. If using a demand-driven approach, optimize buffer level to accommodate lead time variability and demand fluctuations. Fifth step in optimization is capacity and resource planning. So in capacity and resource planning, capacity constraint. Integrated production capacity constraint into your MRP system to align production schedule with available resources. Consider machine capacities, labor availability, and work center capacities. Resource optimization. Optimize the utilization of resource by balancing workload, minimizing bottleneck, and ensuring efficient use of production facilities. Sixth step in optimization, supplier collaboration and communication. In supplier collaboration and communication, first is real-time update. Establish real-time communication channel with supplier to exchange information on inventory level, lead time, and order status. Collaborative planning. Collaborate with key supplier to align production and procurement plan, enhancing visibility and responsiveness in the supply chain. Seventh step in optimization is scenario analysis and simulation. So in scenario analysis and simulation, what if scenario? Use your MRP system scenario modeling and simulation capabilities to evaluate different planning scenarios and assess the impact of changes on material requirements and production schedule. Risk assessment. Identify potential risk and disruption in the supply chain and develop contingency plan to mitigate their impact. Eighth step in optimization, employee training and change management. In employee training and change management, first user training. Train employee on how to effectively use the MRP system. Ensure that they understand data input, system output, and decision making based on the system's recommendation. Second, change management. Address resistance to change by involving employee in the optimization process, communicating benefits and addressing concerns. Now, ninth step in optimization, regular monitoring and continuous improvement. In regular monitoring and continuous improvement, the first is performance review. Regularly review the performance of your optimized MRP system against established KPI. Analyze reports, identify area for improvement, and track progress over time. Second, feedback loop. Create a feedback loop that allow user to provide input on system performance and suggest enhancement for further optimization. And the last step in the optimization, integration with other system. In integration with other system, first point, seamless data flow. Integrate your MRP system with other businesses system like ERP, CRM, MES to ensure consistent and accurate data exchanges across functions. Second, cross-functional collaboration. Foster collaboration between departments to ensure that information flows smoothly and decisions are well coordinated. Now in optimization, optimizing your MRP system is an ongoing process that requires dedication, collaboration, and willingness to adapt. By following these steps and tailoring them to your business unique requirements, you can enhance the performance of your MRP system and achieve more efficient and effective material procurement, production schedule, and inventory management. So this is all about optimizing MRP for business system. Now next, relation between MRP and profit. The relation between material requirement planning MRP and profit is a multifaceted, and MRP can significantly impact a company's profitability by influencing various aspects of its operation and supply chain. Here how MRP can impact profit on detail we can discuss one by one. So first, inventory cost management. MRP helps optimize inventory level by ensuring that material are produced or procured just in time to meet production need. Excess inventory ties up capital and incurs storage cost, while inadequate inventory can lead to production delay and lost sale. Effective MRP minimizes carrying cost while ensuring material are available when needed, contributing to the cost saving and improved profitability. Second, production efficiency. MRP coordinate the production schedule based on demand and available resources. This minimizes production bottleneck, idle time, and overtime cost, leading to inefficient resource utilization and reduced production expenses. Higher production efficiency can translate into cost saving and increase profit margin. Next, timely order fulfillment. MRP ensures that materials and components are available when needed for production, enabling companies to meet customer demand on time. Satisfied customers are more likely to place repeat order and refer others, contributing to increased sales and revenues. Next, minimize stockouts. By calculating material requirement accurately, MRP reduces the likelihood of stockout, which can lead to lost sales and customer dissatisfaction. Meeting customer demand consistently helps maintaining a positive reputation, encourages a customer loyalty, and contribute to long-term profitability. Next, reduce rush order. Effective MRP minimizes the need for last minute or rush order for material or component, which often incur expedited shipping cost. By planning ahead and ensuring material are available, MRP can help avoid these costly expedited orders, contributing to cost saving. Next, optimize procurement. MRP generates purchase order based on calculated material requirement, considering lead time and existing inventory. This optimizes procurement process, avoid overloading and prevent tying up capital in excess inventory. Efficient procurement contribute to the cost control and improved profitability. Seventh, resource utilization. MRP balances production capacity with demand, preventing overloading or underutilizing resources. Effective resource utilization reduces waste, optimizes labor and machine cost, and positively impact profitability. Right? Cost reduction in planning and scheduling. MRP automates and streamlines planning and scheduling process, reducing administrative overhead and ensuring efficient allocation of resources. This leads to cost saving and contribute to higher profit margin. Ninth, data-driven decision making. MRP provide insight into material requirement, production schedule, and resource utilization. Informed decision making based on accurate data can lead to better choices regarding product mix, pricing, and resource allocation, ultimately enhancing profitability. Competitive advantage. A well implemented MRP system can provide a competitive advantage by allowing a company to respond quickly to market changes, offer reliable lead time, and maintain efficient production process. This can attract more customers and positively impact the bottom line, and hence we can achieve profit with the help of MRP system. Now, the effective implementation of material requirement planning can impact various aspects of company's operation, leading to improved efficiency, customer satisfaction, and cost saving. These factors collectively contribute to enhanced profitability and the overall financial health of organization. Next point, output of MRP process. The output of material requirement process is a set of recommendation and information that guide the management of material, production schedule, and inventory level to meet the demands of the business while minimizing cost and optimizing resources. The primary output of MRP process includes plan order release. MRP generate plan order for material and component based on the calculated requirement. These orders satisfy when and how much to order or produce to fulfill future demand. Plan orders can be for purchasing from supplier or for initiating production within the organization. Second output, purchase order. For externally produced item, MRP may generate purchase order that specify the quantity, timing, and supplier detail for material that need to be purchased. These purchase orders are sent to supplier to initiate the procurement process. Third output, production orders. For item produced internally, MRP generate production orders that detail the quantity to be produced, production start and end date, and the necessary resources, labor, machine, etc. for the manufacturing purpose. Fourth output, rescheduling recommendation. MRP provides recommendation for rescheduling existing order based on updated demand, supply, and resource availability. This helps in managing changes and disruption efficiently while managing production schedule. The fifth output, projected inventory level. MRP calculates projected inventory levels for each item, considering planned receipt, production, and demand. This information helps in identifying potential stockouts or excess inventory situation. Sixth output, available to promise information. ATP means available to promise, refers to the quantity of an item that can be promised to customer based on existing order and projected inventory. MRP provide ATP information to support accurate customer order commitment. Seventh output, action message. Action messages are alerts and notifications generated by the MRP system to guide decision making. These messages might indicate action like order release, rescheduling, order cancellation, or adjustment to inventory level. 8 output, material storage alert. MRP highlights instant where demand exceeds supply, indicating potential material shortage. This enables proactive management to prevent stockout and production delay. Ninth output, exception reports. MRP generate exception reports that highlight deviations from the planned schedule, such as item with excessive lead time, excessive inventory level, or overdue orders. 10th output, master production schedule. While not exclusively part of MRP, the MPS is closely related. It outlines the production plan for finished good, providing detail on when and how much to be produced to meet customer demand. 11th output, replenishment recommendation. Based on reorder point, safety stock level and lead time, MRP provide recommendations for when to reorder material to ensure continuous availability without excessive stock keeping. And the 12th output, production schedule. MRP contribute to creation of a production schedule that outlines the sequence and timing of production activities. This schedule ensures that production resources are allocated efficiently. Now, the primary goal of MRP output is to ensure that material are available when needed, production is well coordinated, inventory levels are optimized, and the customer demand is met with minimal disruption and cost. MRP output provides actionable insights for purchasing, production, inventory management decision, helping organizations operate more effectively and efficiently in dynamic supply chain. So this is all about output of MRP process.